All right, folks, it's back in action here. On this page of notes, we are going to wrap up at the example from the previous video, practicing with our elementary row operations, and then we're going to actually jump into two systems of equations, and we're going to use our elementary row operations to solve a system of equations. So up here on the top of your page, I have one last row operation that I want us to practice, and that's where we're going to add the first row to the third row. Now, when we do that, when we add that first row to the third row, what that means is that the first two rows are actually going to stay exactly the same. So we can immediately rewrite those. So I could immediately write the -1, the 2, the -3, and the 1, and I can write the 0, the 1, the 3, and the 4. It's always good to write those ones that you know are going to stay the same. It'll help you kind of keep track of what you're doing. So our last row then needs to become our row 1 plus our row 3. Now this is a good habit to get into. It's going to help you really keep track of what you're doing with your matrices when we're solving our systems. So when I add these rows together, that's exactly what it sounds like. We're going to add the -1 and the 1 and the 2 and the -3 and so on. And that's going to create our new third row. So I'm going to get a 0 from my -1 and 1, and my 2 and my -3 is going to give me a -1. -3 and 5 is going to give me a 2, and a 1 and a 2 is going to give me a 3. All right, so that could be a new equivalent matrix. Now, we wouldn't actually be done if this is where we stopped. I'm going to talk about more of that in the actual system of equations below. But we just wanted to go through those basic row operations. So now looking into this box here, this is really just a description of what we're going to do to solve our systems of equations. So what we can see is there's this method called Gauss-Jordan elimination, and we are not always going to fully follow the Gauss-Jordan elimination. We're not going to fully put things into what's called row echelon form. I'm going to show you guys a few little shortcuts, but we'll talk especially in class about the main requirements that if you were in a course that required you to do all of it, what it should look like. So let's take a look at this system of equations that I have here. So I have a simple system of two variables. You are very familiar with those, and you might be tempted to say, but I already know how to do this with substitution or elimination. And that's true, but having a system here that we're already familiar with is nice to practice a new skill because it allows us to see the connections a little bit better to some of our new skills, and our old skills helps us link those together. So let's take a look at what we can do. Very first thing is always going to be to write the augmented matrix. So that vocabulary from the very beginning of this lesson, we're going to write that augmented matrix. So let's go ahead and do that. So we'll have our 2, our -1, and our 12, and our 4, our 3, and our 14. Now, as I mentioned earlier, we can put in this vertical bar here if you want to separate the coefficient matrix from the constants. I don't typically draw it in, but some people really prefer to see that all along. I'll come back to that idea as we get closer to the end. So what we're going to do is we're going to start to do our row operations, and as I work through these two videos, I want you to focus more on how I'm doing the row operations, not necessarily how I'm deciding what row operations to do. That comes a little bit with practice, and we will talk about that a little more in class. So the first row operation that I'm going to do is I'm going to take my first row, and I'm going to multiply it by 3 and add it to my second row. So I'm going to do 3 times row 1 plus my row 2. Well, that of course then means that row 1 is going to stay exactly the same. So I'm going to rewrite my row 1 to -1, 12. And then I'm going to write my new row 2. So my 3 times 2 is 6, add that to my 4, and that's going to give me a 10. And 3 times a -1 is going to give me -3, plus my 3 is going to give me a 0. And 3 times 12 is going to give me 36, plus my 14 is going to give me 50. All right, now this actually gets us a little bit closer to solving this, and it gives us an opportunity to kind of talk about what are we trying to actually do here. When we solve these systems of equations, we understand that this column represents our x and this column represents our y. So what we're trying to do is ultimately get this to be a 1 and this to be a 1, and then these both be zeros, or vice versa. These could certainly be 1s and these could be zeros. Because remember, our elementary row operations would allow us to reverse these if we wanted. So if my 1 was here, I could just move that row, flip-flop them, so that the 1 ended up in that first spot. So getting a 0 right here is a very significant first step for us. So the next thing that I notice, since I have that 0 here, is that I can then divide this entire row by 10. So let's go ahead and do that as our next step. So I'm going to write it as a 1/10 R2. You could certainly write it as R2 over 10. I just happen to like that fraction there. So that means that my first row is still going to stay the same. So I'm still going to have my 2 and my -1 and my 12. But my second row is going to become a 1, a 0, and a 5. Now that goes right back to what I was just saying is our goal. So let's put that vertical bar in there again. And remembering that if this column represents x and this column represents y, I now actually know that 1x equals 5. So I'm going to go ahead and I'm going to write that over here. So now I can identify that x equals 5. Now, if x equals 5, I can certainly substitute that back into either one of my original equations and finish solving for y. So I will have 2 times my 5 minus my y equals 12. That means that I'm going to have a -2 equals y. So I can write the final answer for my system as that nice ordered pair, that point of intersection. And I would be done. All right, so that's our system of 2 variables, and you should probably feel a few connections there to solving systems by elimination. It's a very similar process. So let's take a look at the system of 3 variables that I have here. It's going to start out the same. We're going to write that augmented matrix. So let's go ahead and write that first. So I'm going to have a 1, a 1, a 1, and a 6, a 2, a -1, a 1, and a 3, and a 3. And here's something that's super important. We've got to write that 0 in there. The 3, the 0, the -1, and the 0. All right. So there's our augmented matrix. Again, if you prefer, you can certainly draw in that vertical bar. It's totally up to you. So what I'm going to do in this very first step is I'm going to notice that I have this -1 right here. So if I take my row 3 and add it to row 2, I'll get a 0. And if I take my row 3 and add it to row 1, I'm going to get a 0. So I'm actually going to do 2 row operations at the same time. So let's write those out. My new row 1 is going to become row 1 plus my row 3. And my new row 2 is going to be row 2 plus my row 3. And then I'm going to keep row 3 exactly as it is. So let's go ahead and write that one first. So I'll have my 3, my 0, my -1, and my 0. Now when I start adding those, I'm going to get a 5. And my 0 and my -1 is going to still be a -1. Oh, now I get another 0, and I get a 3. And then on my next one, I'm going to get a 4. And I'll still have my 1, and I'll have my 0, and I'll have a 6. So now I've created a couple zeros here, and that is a very, very good thing for me. So the next thing that I'm going to notice is that now I have a -1 right here. So if I add these 2 rows together, I'll get a 0 right there. So I'm going to create a new row 1, and my new row 1 is going to become row 1 plus my row 2, and then I'm going to keep my row 2 and my row 3 the same for right now. So let's go ahead and rewrite the original, not the original, my original from that step, from the previous step, row 2 and row 3. So I'm still going to have this 5, I'm still going to have my -1, my 0, and my 3. I'm still going to have my 3, my 0, my -1, and my 0. And then when I get that new row 1, I'm going to have a 9, a 0, a 0, and a 9. Now, here's what stands out on this row for me. What stands out for me is that I now have 2 zeros here, which means if I divide this row by 9, I'm going to actually know that answer. So dividing that row by 9, again, if we want to keep track, we can. This one's a little obvious, but I could write 1/9 row 1. I'm going to end up with my 1, 0, 0, 1. The remaining 2 rows are going to stay the same. So 5, -1, 0, 3, 3, 0, -1, 0. Now, this is especially useful for us. We are actually almost done. In one more step, we can actually finish everything. So what I'm going to do is I am going to write it down here for you first. I'm going to keep my row 1 exactly as it is, so because that one's already solved. So let's go ahead and write that one, 1, 0, 0, 1. And then my new row 2 is going to be a -5 times row 1 plus row 2. And then my new row 3 is going to be a -3 times row 1 plus the row 3. And that's going to create that new row for me. So if I do a -5 times 1 plus my 5, that's going to give me a 0. Well, -5 times the next 2 zeros in row 1, those aren't going to change those values. So I have a 0 plus my -1 is still my -1, and then I'll still have a 0, and then a -5 plus my 2 is a -2. And on the next one, a -5 or a -3 plus my 3 is going to give me a 0. That's going to be still my 0 plus my 0. A 0 plus my -1. And a -5 plus my 0. Or a -3 plus my 0, sorry. Misspoke there. So we are actually almost done. The very last thing that I can see on this one is similar to what we had back here when we were working with our 9. All I need to do is get rid of these negatives. So one last step, sometimes people actually take a little bit of a shortcut when they write this, but our one last step, we can write 1, 0, 0, 1. I can write 0, 1, 0, 2. I'm just dividing everything through by the negative. 0, 0, 1, 3. Draw that vertical bar in there, and remember that you have an X, a Y, and a Z. So now X is 1, and Y is 2, and Z is 3, and that's kind of convenient and cool the way that one turns out. So we can write the ordered triple, 1, 2, 3. And that's all that we have. So again, worry more at this point that you understand how I did the row operations and less about how I knew what to do. And we'll talk a little bit more about that in class.